For this polynomial, using the Rational Zeros Theorem, we find that our possible zeros are 1, 1/2, and these are plus or minus, of course, 1/3, 1/6, and then 7, 7/2, 7/3, and 7/6. And from Descartes' Rule of Signs, we find with sign changes that there is one positive zero, and 2 or 0 negative zeros. So we'll start testing these possibilities. We'll do synthetic division to test. So we put our coefficients 6, -13, -26, and -7. And we start testing. I'm going to go ahead and start with the negatives this time. So let's start with -1. We bring the 6 down and multiply. 6 times -1 is -6. And then add those together. -13 minus 6 is -19. -19 times -1 is positive 19. -26 plus 19 is 7. And, -7. And -1 times -7 is positive 7. And we add those and get 0. Well, that's awesome. We got a 0. That means that -1 is a 0. And specifically, we can say x plus 1 is a factor. And then these coefficients are what's left over after we factor out the x plus 1. So that's 6x squared minus 19x minus 7. And since that's a quadratic, we can just go ahead and factor that. And we should be able to get our other zeros, if, of course, we can factor it. So to factor that, we're going to just try some things out. If you don't remember, when you've got a quadratic with a leading coefficient other than 1, it can get pretty nasty. But one nice way is what we'll do is we'll take this front number and multiply by this last number. So 6 times -7 is -42. And then we want to look for a pair of numbers that multiplies to be -42 and adds to be -19. And it's pretty easy to see that -21 and positive 2 work out for that. And then what we do is we take this quadratic and we're going to write it out by splitting the x term up. Instead of -19x, we'll write plus 2x minus 21x. It doesn't matter which order that you do those. And then we've got our -7. And then we factor by grouping. So we've got this pair here and this pair here. So the 6x squared plus 2x, we can factor 2x out. And we're left with a 3x plus 1. And for this minus 21x minus 7, we can factor out a -7. And we're left with a 3x plus 1. So if we factor out the 3x plus 1, we are left with 2x minus 7. And that's our factored form for this polynomial. So now we just set each of these factors equal to 0 to get our zeros. So x equals -1, we already had that one. For the next one we get -1/3, and then we get 7/2. And we can see that that does match what we were expecting from our Rational Zeros Theorem and our Descartes Rule of Signs. So -1, -1/3, and 7/2 were all in our possibilities there. And we did get 2 negative zeros and 1 positive zero.